Alrighty, everybody. We just got our okay to start the final show here at the Morrison Planetarium. So for now, I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And once again, folks, welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm a person and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show is going to be. I just want to let you know that I'm an actual person. I'm going to be guiding you on our show for the final one for today. And also, folks, everything that you see in purple right now is going to be one really big screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for our projector system, it's hidden just below the purple glow. And folks, the show that we're going to be doing right now is different from all the other ones we've done here today. This one's called Tour of the Universe. And with Tour of the Universe, for the next 30 minutes, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But just a heads up, we're pretty small in the grand scheme of things. And also, folks, this show is completely live, so you're going to hear my voice for the next 30 minutes, so just a heads up. And before we get started with the show, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. There's a few of us in here right now. First off, folks, there's no food or drinks allowed in. If you brought any snacks, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. We thank you. Tough thing to do. And also, folks, if you have any cell phones, smartwatches, anything that produces bright white light, now's the time to put it away for the next 30 minutes, as these can be distracting and takes away from the planetarium show experience. And folks, if you need to leave early, the exits are at the top of the planetarium, so always make your way up the stairs to exit if you gotta leave for any reason. And if climbing the stairs poses a challenge for you, the stairs are very steep, just remain seated. Once the show's over, we'll have someone escort you to a lower exit, so just stay seated for a bit longer as people are heading up the stairs to exit. And last but not least, folks, this show is very immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, you start to experience motion sensitivity, there's a really quick and easy trick to help you. All you gotta do is close your eyes, take in a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, folks, it looks like we're ready to go. So I invite y'all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting out pretty close to the Earth. We're not exactly on our planet, but we can see the Earth just down below. And we're starting off at this really cool spacecraft in front of us called the International Space Station. A lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the news and articles, but I don't really know what it is. Could you explain it for me? Well, yeah, of course, folks. The International Space Station is a research facility. It's a laboratory that orbits around our planet Earth. And they conduct all different types of science experiments up here that's much easier to do much further away from the surface, which has a lot more gravitational influence. And also, folks, this is the largest thing we humans ever put out into outer space, and it's about the size of American football fields. So if you've never been to an American football game, don't worry, you can also use the entire California Academy of Sciences, the museum we're sitting in right now. That's about how big it is. And what's really impressive is that this thing is going really fast. The International Space Station is traveling at a whopping 17,000 miles per hour, where it orbits once around the Earth every 90 minutes. And it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And also, folks, this looks really far away from our planet Earth, but it's not that far either. The International Space Station is only about 225 miles above the surface of our world. 225 miles, for us Californians, that's not too far away. That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. But to tell you the truth, folks, this is as far as we put humans out here in space, only 225 miles above the surface of our world. The reason why? Well, it's very expensive to travel into space. You got to build yourself a rocket ship or buy yourself one, and then you have to buy a lot of rocket fuel. You're going to need so much rocket fuel, you got to be able to leave our planet behind. And then once you're all the way out here in space, you have to account for all the food, water, all the air you're going to be breathing, so that gets quite costly quite rapidly. But folks, this is just the first stop in our tour of the universe, so now we're going to see the International Space Station slowly disappear to the ground below. It looks like we're flying just above Texas, so let's leave it behind. And before we lose track of the International Space Station, I want to add a nice little orbital path so we can see where it is as we start to slowly fade away. Alrighty, folks, we zoomed all the way out and we're now able to see our entire planet Earth in all of its glory. And just to let you know, the space program that I'm using here in the Morrison Planetarium is this program that you can go home and download if you want to fly through space just like how I'm doing right now. The space program that we're using is called OpenSpace Project. So if you go to your favorite search engine, type in OpenSpace Project, you'll come across the link where you can download this. But just a heads up, OpenSpace is in its beta phase, which means it's not completely finished. So we may come across a few bugs and glitches. If we do, I'll point them out. Hopefully we can look past them. And also, this is an open source program. And what that means is that anybody can add to it, but also this uses real-time data from satellites, so it uses a whole lot of processing power and information. So if you have an older computer, you may want to rethink it. But if you got something new like a gaming computer, give it a try. It's a whole lot of fun. But folks, if you're a person like me that doesn't want to download anything, you just want to fly through space with a click of a button, well, we also have another great alternative called NASA's Eyes. Just like the human eyeball, type in NASA's Eyes, and you can find a link and you can fly through space without having to download anything, and it's so much fun. But in here, we're using OpenSpace Project. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor in space, the moon. Now, folks, we humans have been to the moon before, and that was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science, and of course, they had some fun up here as well. They got to play some golf. But again, the last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon in the next few years, thanks to NASA's new space mission in the works called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we gotta figure out exactly how we're gonna be living out here in space. And the moon is the perfect stepping stone about how we're gonna be figuring out, because it's pretty close to us. But what's also really cool with Artemis is that they're gonna be sending the first woman to the moon, but not only that, they're also gonna be sending the first person of color to the moon, but not only that, they're also gonna be setting up lunar bases throughout our moon. Pretty much our technology has greatly improved in the last 50 years, so we're able to do a lot much more science in a much more compactable size. And one place that we definitely want to set up a lunar base is the south pole of the moon. The reason why is because we found ice there. And ice is very helpful because we can melt it, pass electricity through it, and we can separate the hydrogen and the oxygen, and that's very helpful when you're all the way out here in space. So again, we humans should be heading back to the moon in the next few years thanks to the new NASA space mission called Artemis. So look out for any news about it in the coming years. And folks, when we look at the moon here on Earth, sometimes the moon feels incredibly close. Feels like you can reach out your arms and touch it. But the moon's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. Astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so or since, it only takes light 1.5 seconds to cross that distance at the speed of light. Whew, that's really fast. That's like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth's orbit as they start to slowly fade away. In fact, before we lose track of it, I want to add a nice little orbital path because, again, space is really big. It's hard to see everything when you're really far away. So here are the trails of the planets and the moon. And now, folks, on our journey, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to computer models like OpenSpace, showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun. Do-do-do-do-do. And folks, the sun is also incredibly far away. It's roughly about 93 million miles away from our planet. Whew, 93 million miles. That is a good distance away. But in terms of speed of light, that's not too far away at all. And again, we're the third rock from the sun. So 1, 2, 3, that's us. 93 million miles between the Earth and the sun. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light. So that's really fast. And this is a cool concept because let's say the sun was to turn off all of a sudden, no more sunlight was being emitted. That last bit of sunlight will travel at 93 million miles, that 8.5 minutes at the speed of light, and then all of a sudden the daytime on Earth would become nighttime. And again, this is a cool concept to keep in mind because let's say we're looking at a star 70 light years away from us. We're looking at that star as it looked like 70 years ago because the light that just reached us took 70 years to get to us. So when you look at really far away objects in space, it's like looking back in time in a sense. Pretty cool. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what we got. Right in the middle of our solar system, we have our star, the sun, biggest thing by far. The closest planet to the sun, we've got Mercury. Then we have Venus, Earth, that's us, and Mars. These are the rocky terrestrial planets. These are places where we can land a spacecraft on. And then past the orbit of Mars, we have this thing called the main asteroid belt. And this is what it would look like to highlight all the asteroids in the asteroid belt. There is a lot of them. And then past the asteroid belt, you have the really big planets. You have the gas giants. You got the Jovians. We have Jupiter right over here, the biggest of them all. Then we have Saturn, famous for its rings. And then we have our icy gas giants. We got Uranus, the funny one, and then Neptune all the way over here on the right. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here's the orbit of Pluto on screen. And Pluto's on the very bottom right over there. And people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering to yourself, what's the Kuiper Belt? I've never heard of that before. Well, folks, this is the Kuiper Belt. Yeah, whoa. So, way out here past the orbit of Neptune, we have the Kuiper Belt region, and this is pretty much a second asteroid belt, kind of like our main asteroid belt, but all the way out here, you're mostly going to find icy asteroids and short period comets. And we came across this in 2006 because our space telescopes improved. We're able to see much further objects, much smaller objects much further away. And that was the day when Pluto went from being a planet to a dwarf planet because we found more than 400 objects out here. We can call all this stuff planets. Most of these things were bigger than Pluto. So all the astronomers on Earth had a great big meeting. They had to figure out what exactly you need to be considered a planet. And then they came up with 3 criterias. And again, that was the day Pluto went from being a planet to a dwarf planet. So that's the really cool thing about science because as our technology gets better, we're able to find new things and we're able to redefine what we already know. So science is constantly changing. But I want to put away the Kuiper Belt because that's just a whole lot to look at. And now I'm going to be putting on screen the many different spacecrafts we sent out in the 1970s to explore our solar system. So now on screen, we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2, and the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. All of these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes roughly about 5 hours at the speed of light. 5 hours to get all the way out here. Not too bad either. But folks, it's time for us to leave our planetary scale behind us. So now we're going to see our solar system start to slowly fade away. And now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. And all the way out here now, our star, that sunshine, becomes another star all the way out here with all the other stars. Ooh, wow. We flew right by Alpha Centauri. So Alpha Centauri is that star that's right in front of us. So again, we're right in the middle of our screen. That's our solar system, Alpha Centauri right in front of us. And again, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us humans to get all the way out here. Well, folks, if you want to get in a spaceship of today, fly over to Alpha Centauri. It's going to take you about 8,500 years. Whew, and that's just a one-way trip. And now, folks, let's stop consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we're now inside something called the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted, or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light. So this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is constantly expanding at the rate of 1 light year per year. So is anybody out there listening? And now, folks, I'm going to be adding some many markers onto the screen. These many markers indicate some of the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it here on our planet. So far today, we found 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you looked over here, you can see we point our space telescopes in one direction for many years, and we found a whole heap of exoplanets. So as they continue to scan more and more of the night sky, we'll be finding exoplanets left and right. So that 5,000 number will be increasing. Not to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. Pretty much new space telescopes are being developed right now, so we got a few years before they're launched into space, so we can't answer the question quite yet. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signal. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos can be decades in time. To give an example, let's say we live in a star system over here on the left of our radiosphere. We find an alien civilization on the other side, on the right side of our screen. We shoot them a text message. It takes 60 years to get to them. They listen in, answer back, and takes another 60 years to get their response message. Folks, that is a 120-year conversation in the making. Whew, and I don't think I could live that long. But of course, planetary systems beyond our radiosphere more than 90 light years away have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away our exoplanet markers. But I'm going to leave our radiosphere up on screen because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, folks, we're looking down at our Milky Way galaxy. This is the galaxy we live in. And I've got to ask, can anybody see their house from here? Just kidding, we're way too far away. And folks, our Milky Way galaxy is huge. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years at the speed of light. This thing is big. And our Milky Way is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood within this vast star city is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave the Milky Way, if you look at it from a sideways perspective, you'll notice that we live in a big flat spiral disk. Kind of looks like a big pancake. And this is important because when astronomers and scientists want to learn about the universe, it's easier for them to point their telescopes galactically north and galactically south, instead of looking to the plane of the Milky Way, which has planets, stars, gas, things that block their view of the universe. So again, we like to point our telescopes galactically north and south. That's going to come important in just a little bit. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. Now, we live in a local galaxy group, which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And as our picture expands, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or voids, no galaxies at all. So we can see a nice galaxy cluster towards the middle, we can see some towards the bottom as well, we can see very few galaxies on the left side of our planetarium dome. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, this picture that we're looking at represents the closest 30,000 galaxies to us in space over 300 million light years. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tully, who worked at the University of Hawaii, who compiled this amazing representation thanks to works of other astronomers working aside him over decades of time. But now, folks, we have automated systems that are mapping even the most distant galaxies. So now we're about to see the large-scale structure of the universe. And remember, every single point of light, that's an individual galaxy, not a star. And folks, the large-scale structure of our universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a big flat spiral disk of our Milky Way? If we were to line up our Milky Way galaxy, it would run down the middle of our screen, up and down, just like so. So again, we like to point our telescopes galactically north and galactically south. But astronomers still want to make sure that there was galaxies through the plane of our Milky Way galaxy. So we have this nice purple survey right in the middle. You'll notice that we are still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to see or map out all these areas that haven't been filled in yet. So it's just a matter of time. And it looks like we're running low on time, folks, so we got to continue pressing on. And now we're going to be encountering these really distant, faraway objects known as the quasars. Quasars are short for quasi-stellar radio sources, and they're going to be orange dots on either side of the large-scale structure of the universe. And these blazing objects are all billions of light years away, so now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe. And before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. And here we are, folks, at the very edge of the observable universe, or what we like to call the cosmic microwave background image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. This is data compiled by Planck and other radio telescopes. And this picture is a very baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And this isn't your typical photo either. Instead, this is a temperature density image, where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas, the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really tiny differences eventually gave rise to the large-scale structure of the universe that we saw moments ago. That clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of light years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go. That's going to be back towards planet Earth. So let's find a nice entry point through all these quasars and galaxies. This looks like a good spot right here. And let's make our return trip back to planet Earth, everybody. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. We live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, everybody, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way galaxy. We're heading straight for that radiosphere. Now we're making our way to our star system, our solar system, our little neighborhood all the way out here in space. And now we're about to pass the spacecrafts we sent out in the 1970s to explore our solar system, passing the orbit of Pluto, the Kuiper Belt region, and also making our way to the third rock from the sun, our homeworld planet Earth. All the people that we know, love, ever existed, and learned about in history all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with us today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound just in time for dinner time. And with that being said, folks, that's all for today. Thank you so much for stopping by, and I hope y'all have a safe trip home.